Hello class, and welcome to a new session for today. And in this session, we'll be treating a new topic, which is the simultaneous equation. And under this topic, we're going to be solving a lot of examples. Okay, let's start with this. Now, what is simultaneous equation? Like a simultaneous equation is just like a system of two or more equations involving the same variable. Now, when you hear the word simultaneous, what does it mean? When they say someone do something simultaneously, that means you are doing more than one thing at the same time. So when you are solving two different equations at the same time, two or three or two and above equations at the same time, that means you are performing a kind of a simultaneous equation. Now, and the goal of a simultaneous equation is always to find a single pair of values s and y, sy, that satisfy both equations. That is, now, for example, look at this example. Now, when you solve these two equations simultaneously, then you are solving at the same time. I want to find the value of s and y that will satisfy the two equations at the same time. Now, we have various methods of going about that. So we have the substitution method. The substitution method. So we also have the elimination method. Then we have the last one, which is the graphical method. So under this topic, we are going to be treating, under this session, we'll be treating majorly the substitution method and the elimination method. But the graphical method will come in the later part. Now let's check out this example. We are to solve, okay, using the substitution method, then we want to use the first method, which is the substitution method. Solve simultaneously y equals to 2s plus 1 and 3s plus y equals to 11. That means we want to find the value of s and y that satisfy these two equations. So for me, you have y to be 2s plus 1 plus 1. And let's call this our equation 1. Then you have 3s plus y to be equal to 11. And let's call this equation 2. Equation 2. Now, originally from the first equation, you already have your y to be equal to 2s plus 1. Now, from equation 2, you can still substitute for y equals to 2s plus 1 in equation 2. That means in equation 2, anywhere you see your y, you put 2s plus 1. So you have what? You have 3s plus y, and from equation 1, y equals to 2s plus 1. That means it will be 2s plus 1. So this is our y. Then equals to 11. So you have 3s. When you expand this, and when you open the bracket, it will be 2s plus 1 to be equals to 11. So from here, 3s plus 2s will give you 5s plus 1 equals to 11. So you have 5s. When you collect the like terms, 1 will go there, so you have, it will become 11 minus 1, and that will be 10. So you have 5s to be equals to 10. So when you variable side by 5, and your s will be equals to 2. That means the value of s will be equals to 2. Now, we want to find the value of y. Now, recall, so from equation 1, y equals to what? 2s plus 1. So you have y to be. So anywhere you see s in this expression, we are going to say our s value to be equals to 2. So you put 2 for it. So you have 2. S is equals to 2 plus 1. So you have y to be 4 plus 1 and equals to 5. So that means the value of s is equals to 2 and the y is equals to 5. So that's the value. So the two values, s and y, that satisfy these two expressions at the same time. is equals to s is 2 and y is 5. You can test it, you can confirm. So if you come back to your equation 1, if you put s here, s will be 2 here, that will be 4 plus 1, and the y becomes 5. So you have y to be 5. And when you come back here, if you put s to be 2, 3 multiplied by 2 will give you 6, plus y is 5. So 6 plus 5 will give you 11. So the two values that satisfy these two equations are s equals to 2 and y equals to 5.